Okay, so let's see how you did on this one. I understand that I'm trying to give you a whole bunch of different types to look at that are in the same genre so that you have more examples. So I don't know how you did with this. I'm hoping it was okay. Remember that the first thing we have to do is solve for x. This one's easy. This is going to be a -2. This one's easy. This is going to be a -3. This one I'm not so sure you remembered how to do, so I'm going to do a little bit of work over here. We want to set this equal to 0 and solve for x. So I would add 5 to both sides, and then I would divide by 2. And you can either leave it as 5 halves or you can divide it so that you know where it is on the number line. So that's 2.5. And it's a squared, which means it's going to bounce here. B. Okay, so we've got a bounce at 2.5. We've got a single root at -3 and a single root at -2. The other thing that we want to make sure we do, and I'm just going to kind of get it maybe right down here, is the y-intercept. The y-intercept, when it's factored, it's easier to plug 0 in. So this is going to be 2 times 0, which is 0. Minus 5 is -5. Squared is 25. So that's going in the first spot. 0 plus 3 is 3. And 0 plus 2 is 2. So I've got 25. I'm going to do times 2 is 50. And 50 times 3 is 150. So that means that our y-intercept is 0, 150. So that's positive, which is kind of neat. Next, what we want to do is look at the shape of this thing. So we have a bounce, so that means there's 2 already, and 1 and 1. So this is a 4th degree, which makes this a quartic. Now, typical quartics resemble M's or W's, and all of our X values are positive, so we're looking more at a W shape because it starts up and ends up. Our end behavior for a quartic looks like that. Okay, I'm going to go ahead and get my sketch set up, and I will see you in a second. Okay, so I got my sketch drawn, and again, I'm just putting the ones in because I just feel like it makes it a little bit neater. So I know I need a -2 and a -3, and I also need a positive 2.5. So that's why I made my sketch the way I did. Keep in mind that we've got to bounce at 2.5. Oh, and I forgot. Are these open circles? Why, yes, they are. This is open circles because there's no equal to sign. So make sure that you are making open circles on your sketch, that at 2.5 you have an open circle. At -2 you have an open circle. At -3 you have an open circle. We also need to make sure we pass through 150, which is good. And what we're going to do now is follow our quartic path and start at the top. Don't forget we're bouncing, but it's over here. Okay, so we're going to start top left. We're going to come down. There's our W, kinda. We got to hit this one way over here. And then we're going to come back down, and this is where our bounce occurs, right here. Boom, and back up. That's a pretty interesting W. So there's our quartic. That's our sketch of our inequality. Now it's time to shade. This is a less than. We know less than means that we're looking for a dip in the graph where it's below the x-axis. Luckily, there's only one itty-bitty section. Look at this whole thing. This only dips underneath between -3 and -2. Now they're open circles, remember. So that means that when we go to write our interval, that we have parenthesis, -3, comma, -2, close parenthesis. And we're done. That's it. That is your answer to this inequality.